Hi guys, welcome back. Last session we introduced transistor and what are the different modes of operations or regions of operations we discussed. Now in all the modes of operations what we discussed, first one is we discussed saturation region, both emitter junction and collector junction should be in forward bias. The next one, cutoff region, both emitter junction and collector junction should be in reverse bias. There it acts as an off switch. Now saturation region on switch, cutoff region off switch. Now in these two regions of operations mostly we observed in digital applications. Whatever the digital electronics you have, in that you observe your transistor to operate in these two regions. Next we move to active region. This is the heart of the electronics. Now transistor is heart of electronics and operating the transistor in active region is heart of amplifiers. Once students learn about electronics, once they have little bit idea, immediately they think of amplifier. Okay, why? Because in practical applications, whatever the signal or whatever the information we are getting, that information is not having sufficient strength because it is traveling so much distance, maybe through conductor or through wire or wireless. Once you get that, you need to amplify that because the signal you are getting is having very small strength. It is unable to operate some device what you are using or unable to make your make proper sense. Now I need to amplify that signal. Once we amplify the signal, then we can easily view that, wow, it is a beautiful picture, it is a beautiful sound, it is a beautiful song. Like that we can get clear idea, clear information we can get. Okay, now for that the basic device we are using is transistor, and that too the transistor should act as an amplifier. To use your transistor as an amplifier, it should operate in active region. Okay, so active region means emitter junction is forward bias, collector junction is in reverse bias. Emitter junction forward, collector junction reverse bias. Okay, now first let us, I am taking a simple transistor, I am going to connecting that in active region. See, this is my transistor. Collector, emitter, base. So it is a NPN transistor. Okay, default I am taking a common emitter configuration. Should be forward bias, emitter junction, collector junction should be reverse. Now to forward bias, P connected to positive, N connected to negative. For reverse bias, it should be N connected to positive. Now the transistor is in active region. So how many power supplies you are using? That is the point here. One power supply, the second power supply. Two power supplies you are using to operate your transistor in active region. That is the drawback in this. So you should operate your transistor in active region with single power supply. Okay, that is our motto. Now, so to operate your transistor properly in active region is called biasing. So now we are giving high priority to transistor biasing. And one more, we compare this with the practical application. Practical application. Let us, I am taking a TV. So this is the common electronic appliance nowadays. This is TV. So for this TV, you need to provide proper DC supply. Proper DC supply. It is power supply. DC it is. Now you are getting some cable connection. So that is small signal. It is cable connection. Okay. So this is small signal. small signal. It is of the order of millivolts. Millivolts. Don't confuse. Millivolts. Of the order of millivolts. Now, once it will take the signal, it will provide the whatever the video and audio in that signal, it will provide that. First, to provide that, you need to provide proper power supply to that. That means you need to give a proper power supply to that connection, to your TV. You have TV. For that TV, you need to give proper power connection. Without power in our home, we can't view the TV, even though we have cable connection. Even though we have cable connection, without power, we can't view that. Okay. So proper power supply you need to use, and this power supply is going to activate all the electronic devices which are present inside of your TV, and once all are activating properly, then those components take this signal and they will do their work, and finally we can view video and audio properly. Okay. Okay. Now this is called biasing. So whatever the power supply required to activate all electronic components in your TV, that is biasing. Now this is your amplifier. Let us change your TV to amplifier. So to use your transistor as an amplifier, it should operate in active region stably. If it is coming out of active region, it behaves like a switch. So it should be operate in active region. So to operate this in active region, you need to provide proper power supply. Not only this, some additional components also you need to add. That is biasing. Transistor biasing. Now see this. First, so see this. Now transistor biasing. First, you should know what is transistor biasing, what it is. How can I express, how can I define, how can I understand what is biasing? See my dear students, definition is different. Okay, understanding is different. Okay, definition is required for writing on paper. Understanding of that one is required for using that one in some applications. Okay, so not only definition, first you can understand that effectively. So far what we know what is active region, what is saturation, what is cutoff region. Now leave about saturation and cutoff. Now we are in active region. That means our transistor is in active region. In active region only our transistor acting as an amplifier. So don't mind, please, I am repeating number of times this active region because it is very, very important. Now what is transistor biasing? So in in region of operation point of view you can define, in current point of view you can define, in external things, that means external components like your resistors, power supply point of view also we can define. In all the aspects we can define the biasing. Okay, that means once you are changing some power supply, you should know why are you changing that. By changing that power supply, what happens to this transistor, which component of the transistor is changing, you should know the effect of that. For effective understanding of that, this number of ways of defining the transistor biasing you should know. The first one is operating the transistor in active region. Operating the transistor in active region is biasing, because in active region only it is acting as an amplifier because of that. Second one, to provide proper base current. See this, by giving this power supply I am going to providing some base current to this. Now this base current will take your transistor into active region. Okay, So whatever the base current you are providing, you need to provide sufficient base current such that to take your transistor into active region. Okay, so that is biasing. See, IB such that to take the transistor into active region. So here active region, here active region, it is taking your IB. So by in view of IB, I am defining active region. I am defining biasing. Next, once IB taking your transistor into active region, now it should be in active region continuously. It cannot come out of that. Should be in active region. So for that, to maintain constant collector current is biasing. Why? Because once your transistor is entered into active region, it will provide some collector current. Now from this IB, the collector current what you are getting is beta times IB. Okay. Now once IC is constant, your transistor should be in active region, continuously in active region. If it is changing, and what are the parameters changing the IC, and we discuss everything in later sections. Next, proper selection of supply voltage and external resistors is also called biasing. See, not only this one, now we need to provide a resistor here, we need to provide a resistor here. This is also biasing. Which value of resistor we need to use? 1 kilo ohm, 2 kilo ohm, 3 kilo ohm or 500 ohms? Which value of resistor we need to use? That is also biasing. Okay. Now how much voltage we need to apply? If I am applying more voltage, it will take your transistor into saturation. So proper selection of this value also biasing. Okay. Finally, what are the things you can apply? Your intention is to operate our transistor stably in active region. That means continuously it is in active region. You may ask one thing, sir, I am keeping my transistor in active region. Okay, I connected proper resistors with power supply. I operating my transistor in active region. Okay, very good. But without your intention, due to some mechanism taking place inside of your transistor, it is coming out of active region. Without your intention, it is try to come out of active region. So you need to provide some additional things to that. That means some additional components you need to add to that, such that it should not come out of active region. It should be in active region. Okay. So this is the meaning of proper biasing. Next session we discuss what are the requirements of proper biasing of a transistor. What we need to do step by step. We take our transistor and operate it in active region. Once we entered into active region, what is the collector current there we are maintaining? Okay, we just take this, and what is the voltage for that respect to collector current provide? We call it as operating point. Okay, next session we discuss about those things. Thank you.